For many students, math and science can be pretty intimidating, maybe even boring. But there's a group of Fresno State students that is proving that physics can be fun. The group is taking that message to the classrooms of schools throughout the valley. You've seen them on CVT before, but we've invited them back for yet another science lesson. Joining me today is Don Williams. He's a lecturer over at Fresno State, and Dr. Carol Freibohlen from the Education Department. And we have a couple of students here that are going to be demonstrating some of their experiments. So welcome to the show, all of you. I'm going to start with you, Don. Tell us how you and Dr. Freibohlen got together, because she's new in the department.
She is. She's my new partner, right?
Okay, got it.
We were just building this team. You know how we're expanding on this stuff. Exactly. And the bottom line, I said we were actually at a meeting where we were interviewing some people via Codart, and all of a sudden Carol came up to me and says, "Hey, are you Don Williams?" I said, "Yeah." And I could tell right away she was an exciting lady. And we started talking, and I could tell right away we were going to have a good thing here. And sure enough, she's brought me tons of students. We've done nothing but build this thing up. It's just getting bigger and bigger, and more students. You know, remember when we went to your son's school? Was that a big hit too?
Yes, did, and they loved it.
I bet they do. I bet they still talk about it even.
They do, about lying on the bed of nails. I mean, it's really a great way to show kids that science and physics can be fun, right, Dr. Freibohlen? Because let's talk a little bit about that. What is the mission here aside from that? I mean, you brought in more science students, but is it to go to these classrooms to visit the little ones?
Well, it's two-pronged. When I met Don, it was like, okay, this sounds like a really intriguing idea. This is very exciting. And then I saw him in action in the summer with a bunch of kids from kindergarten through 6th grade, and I thought, that man is the Pied Piper of physics.
The Pied Piper of physics.
Very good.
And so I said, we have got to get students in here because this could be a win-win. We could have future teachers from kindergarten through 12th grade learning science deeply, because when you teach, you learn twice. And so they would benefit, and also the students would benefit greatly that they would go into the class and teach the physics.
Were you at Fresno State before as well, just in a different department? Is that?
Actually, I am a professor of mathematics education in the Crimmins School of Education and Human Development. I've been there for 22 years. I also direct the Mathematics and Science Teacher Initiative, and this is a grant that is funded by the Chancellor's Office to support mathematics and science teachers.
And you do it obviously in a fun way. So let's get right away to the
So we're going to start with Manuel, and he's going to show you a little electromagnetism here.
And these are the kind of experiments that you do when you go into the
Exactly, we do
classrooms.
them. Exactly. And then we explain them in detail, which we won't have time to do here today, but we're going to show you anyway. Go ahead,
Manuel, go ahead.
Okay, so we all know...
Let me get a mic to you. Hold on.
There you go.
Okay, go ahead.
Thank you. So we've all seen a permanent magnet, a ferromagnet. I'm going to demonstrate here an electromagnet using a regular household battery to supply the current, wire wrapped around this nail, and if we connect them here and have the current run through, we can
okay, hold on, keep it right there so the camera can, okay, right there.
Yeah.
Go ahead.
So as you can see here, we can produce a magnet just by using electricity, this nail and this wire. Now I have a bigger version here. We have our current coming in through, and then we see the wire going around this nail. And I have a circular conductor, which is using Faraday's law. It's going to, once I produce a magnetic field, it's going to produce a current that's going to loop around this conductor, and it's going to make an opposing magnetic field. So when I put this on here and turn it on, we're going to see this jump up.
Okay.
So get ready to catch it, Alex. Get ready to catch it.
Whoa! Fun!
Now, if this is another conductor, but it has a slit through the middle, which doesn't allow the current to go all the way through. And if we try to do the same thing here, we can see that it doesn't work.
Wow, that's so interesting.
And then Claire's going to show you how metal expands.
Come on over here,
She's
Claire.
got a torch.
So yeah, what we're going to do is just fire this up. Like Don said, just metal expands when it comes in contact with heat. So I'm going to heat this up, make sure it's nice and hot. So it's expanding right before your eyes, right? What we're going to do is try to fit the ball into the ring. Normally it doesn't, so make sure this is just really, really hot. And what we're doing is we're exciting the molecules that's in the material, in the metal, right? So let's see how this goes. It should fit right through.
Oh my gosh!
Very good, Claire. And Jackie's going to show you some suction cups there.
All right, so we've all seen suction cups, Mission Impossible, Spider-Man. So the idea is atmospheric pressure. First we squeeze out all the air, then go ahead and try to pull this apart. You see how strong it is? But as soon as you put air in it, you can pull it right off. Now another suction cup is this.
Yeah.
Everybody's seen these before. Go and try to pull this. Nice.
No, can't do.
Very
Okay.
big. Very the squeeze wants to be the air in, it comes right off.
Wow.
Another one that's special for Dawn is this. Doesn't look like a suction cup at all. I'm gonna put it on the table, squeeze out all the air. Make sure there's no air inside. Go ahead and try to lift that up.
Oh my God.
Once you go ahead and lift up a corner, you can take it right off.
Oh my gosh. Well, that seems like a logical thing.
All right, Curtis is going to show you some of the basketball.
All right, Curtis.
All right, so this is linear momentum, and this will go quick. We have a basketball and a tennis ball, and you guys know how basketball bounces and how a tennis ball bounces?
Yeah.
And so here's a little special trick that we'll show you with the basketball and tennis ball. Watch the tennis ball. Just flies right out of here. Would you like to try that?
Yeah. Okay. Hold on. You hold this mic and you talk into it. Well, I just put this on top of here and bounce it?
So the basketball and the tennis ball drop at the same rate.
Okay.
So when they hit the ground, the momentum travels back upwards, but through the tennis ball.
Oh, wow. So it travels to, that's really interesting. Well, now we only have a couple of seconds, but you have to make your famous ice cream while
Let's
you're
make some ice cream here. We're going to make some ice cream, and Emmanuel's going to be pouring in the liquid nitrogen.
Okay.
I'm going to be stirring, and you know we use half and half cream, and brown sugar is our secret ingredient. And here comes the liquid nitrogen, guys. It looks like water, doesn't it?
Yes.
But it's not. It's liquid nitrogen, and we make it in about a minute.
So liquid nitrogen, brown sugar, and?
Half and half.
Half and half.
And cream, and that's it. That's it. That's probably good, Emmanuel. I think we have it.
You can do this on Halloween. This
yeah,
is
right, exactly.
Now, where do we get liquid nitrogen?
Yeah, that's the problem. You can't buy that at Walmart, guys. You can't do that, right? Look, we have ice cream.
Wow. And let me tell you something. It is really good ice cream. That's why we invite you back. You know that, Don, right?
Yeah,
because
we
get
always
ice cream
bring it,
at
don't
the
we?
end. Well, listen, thank you so much for being here. This is amazing. And I'm going to tilt it this way to show everyone just how fast it became ice cream. And the more it sits there, the harder it gets.
Yeah, well, we got to probably add a little bit more nitrogen. We got a little bit hurry. We got a little bit more nitrogen.
All right, well, go ahead and do that.
You got it. Let's do a little bit more because we got to feed the crew.
Dr. Carroll, let's talk about how people can get hold of you if in case they are interested in maybe having you guys go out to their classrooms.
Okay. I'll give you my email address. That's probably the easiest thing. It's Carol B, C-A-R-O-L-B, at csufresno.edu, or you can look me up.
Well, thank you.
And we are still looking for mathematics and science teachers, and anybody who is interested in becoming a math or science teacher at Fresno State is still accepting applications for spring.
Okay, well, thank you so much. And you could also call the number that you saw on your screen there, 278-1434, and get hold of Don. And we do have to mention, though, that liquid nitrogen is pretty dangerous.
Yeah, minus 200 degrees Celsius.
Yes, so we don't really want to do this at home.
No.
We'll leave it for the experts here. Hey, you guys were awesome. Thank you so much, all of you, for being here. And let's look forward to more science, math teachers, and students as well. Appreciate it. Okay, I'm going to have some ice cream. It's always really good. And then toss to break. Thanks for being here.
Thanks,
Alex, for having us.